Hey, welcome to the spring semester exam review and for pre-calc 2016. Now, one of the first things I wanted to do is that this is going to go kind of quickly, but I want you to be able to pause the video, go back, and then also be able to replicate what you did. The most important thing that you want to do is make sure that you do not catch yourself just watching the video and not going back and trying to see if you understand it. Now, some of these parts, like the first couple of problems, these are pretty easy. You know, they ask you what is the domain. The notation is really like that, and the reason it doesn't exist on 2 is because there's an asymptote there. And on the range, it doesn't exist on y because there's an asymptote there. Now, the intercept, this is the only intercept there is, and there's the value. And the horizontal asymptote, it's listed there as well. Vertical, same thing, x equal to 2. Now, the reason why x is because it's a vertical one. So to describe vertical, just like that. Okay, great. Now, one of the most important things when you go into these interest formulas, which is number 2 and 3, is first of all, this is a formula, you have to memorize it. The other thing is this. Let me kind of undo that, do a little bit better, and then point something out to you. On this part right here, the 3.9, you got to make it into a decimal. And if you don't, which is like right here like this, it will cause an issue. And the other thing to keep in mind, the compounding periods. They're there, 52 and 52. And for the next one, for question 3, compounding continuously means you use this equation called PERT. What I love about PERT is that it's very easy to use. Same thing, 11.9 converted to a decimal, 0.119, and then you have the power to go ahead and solve this. Okay, let's go ahead and move on. Now, these next couple of ones, these are ones that we do by using somewhat of the Straighty method. First thing, you simplify. The first thing I did was I factored this. So there was 2 factors. I got it from -3. And then from there, I also factored out a 2. The thing that was important is that this became my simplified function. So after, like I said, since I'm going quickly through this, pause it, write the stuff down. But one of the things that was important, and when they ask you to find a domain, I could tell from here that it did not exist at -2, +2. If you put those values in there, you'll get a 0, and you cannot divide by 0. Big no-no math. It's an error. It's undefined. Now, as far as finding the x and y intercepts, those are pretty easy. You take the numerator. So in this case, we had x plus 3 as a numerator and x minus 1. And as you can see, I solved for them, and then from there I was able to achieve and get the powers for the x-intercepts. Now, for finding the y-intercept, this is the y-intercept right here. It's pretty simple. All you got to do is put 0 for the x's, and you get your solution. And then when you want to find the vertical asymptotes, they're listed as here as well. So they're at the locations where the domain does not exist, which is the denominator in your simplified function. And then when it comes to finding horizontal oblique asymptotes, you got to look at the equation. And one of the things we identified that was, or discovered that was important, is that it's balanced. So you get y equals 1/2. And then it says determine if your graph crosses a horizontal. It does. And the way I was able to achieve this is that I looked at the value where my horizontal is at. I put it back in the equation for y, and I was able to get the solution. So let's go back. Pretty much this one's the same thing. As you can see, this one was already simplified, but I had to find a domain. This one had the x and y intercepts. They're both the same. So that's one thing. And then the vertical, that was pretty easy to find. Again, has to do where it doesn't exist. And this one was bottom heavy. And one of the things I'm guaranteed when I have bottom heavy is that I have a horizontal asymptote. So I write horizontal here when it's bottom heavy. And also cross, and it crossed at 0, 0. And then I went ahead and graphed it, which is right over here. So you can go ahead and do that. Pause the video and go ahead and graph that. And at the same time, pause at different points and write the stuff down. Now, this last one, I was able to factor the denominator to get this. And the power that I had from that is I was able to find the domain. There was no x or y intercepts because there was no x in the numerator. We did have a y-intercept, and we also had vertical asymptotes, as you saw here. Same thing, this one was bottom heavy, so you had y equals 0. And this one did not cross. Did not. No. Okay, great. Let's move on. Now, with this one talks about polynomials with the multiplicity. The biggest thing you got to do is take this, and when you write it in binomial form, you got to put the opposite in it. And you see how it says multiplicity of 2? That's the reason you have that. This is a multiplicity of 5. That's the reason why you have that. And this one just says a 0, so that's how I created this. It was 1. The thing that was important is that all these, the 3 circle ones, 2 plus 1 plus 5 equal to 8, and that's how you know you have it correct. Now, when they give you the actual equation, the thing that you have to do in order to tell if it's right is actually solve. Like, this one produces -1. That's where you have a 0 at. And this one, it leads us to discovery multiplicity of 3. This one tells us 3. This one tells us 4. 4 and multiplicity 1. Now, anytime your multiplicities are odd, crosses. Even, like the power of 4, turns. Odd, crosses. And then the power function, if you look at all of them, I got this answer because I took 3, 4, and 1, added them together, I got 8. This is how I achieved, and I was able to discover the power function we had here. I got that result. Okay, now for this one, to get this, just form the polynomial with the given zeros, and then you must factor it all back. Okay, this is what I did. Each of these produce these polynomials, or these binomials, I'm sorry. This one's that one. And one of the things I did is that I started distributing. I distributed these two first, and then these two. And I got the solution. I continued distributing. Now, what ends up happening is that this last step, I did it 3 times. So I had a turn, I think up to like 9 terms up here. And when I was able to simplify, I got the solution. But I need you to try it. Do the same steps. Again, don't just, you got to be sure to try this on your own. Okay, now for this question, now this one is probably the only page that came out dark. The thing to get to remember is that this last one, most of the time you hear about P's and Q's. While this one, you got to think a little backwards. It's P and Q, but reverse. This is P, and this is Q. What you do is you find the factors. This is the possible list. And then after that, I graphed it, and I was able to find out that through synthetic division, that this was a factor. And what you did, that 1 was a factor, and -3 was a factor. Now, the thing that's important is that when you this is a multiply column. So it's going to be like 1 times 2 is 2. And then this is the add column with the coefficient. So then 3 plus 2 is 5. And that's how you go through the process of each one. So I got to make sure that you try that out and actually do it. Now, the thing that was lovely after that is I brought this down to a binomial. Use the A times C method. And then after that, I was able to actually factor it. Remember, the biggest thing, these were my factors, is you got to divide by A afterwards. Remember, A being 2. And then once you divide by A, I was able to solve and get the rest of the answers. This one just wanted to list all the possible zeros again. Q's and the P's and Q's. You list out the factors, and then you write out the complete list. That's what you see here. So again, pause the video, write it down, but also try it on your own afterwards to see if you're able to do it. Okay, now when it comes to complex zeros, one of the things that we're guaranteed is that we're guaranteed that we're going to have, anytime we have a positive I, we're going to be guaranteed a negative I, which means that you're just guaranteed 2 complex zeros. They never come in odd numbers, they always come in even numbers. And the other thing that you're guaranteed is that you also have that the real number stays the same. So if you notice, this 3 and this 3 are exactly the same, but what's different is these 2. And these are the 2 missing zeros right here, the -5i and the +2i, because they showed up as opposites on the other side. So that's one of the things you're guaranteed. You're guaranteed opposite conjugates. They're called conjugates, the little last part right there. So that's important. Just important to know as far as terminology. If you keep on taking math, they're going to keep on referring those as conjugate. The thing I love about this one was pretty easy just because +2i means I'm guaranteed a -2i. Now afterwards, what do you do? Well, in order to form a polynomial, I went ahead and made the binomials, and then I went ahead and distributed this answer. So I finally got the solution here. Again, pause the video, write all this down. Now let's go back over here. It says include all complex zeros. Now with this one, if you ever notice an x to the 4th, which this one was, and then the square in the middle, it's very similar to the regular factoring, and it was. And all I had to do was write out a few factor terms, discover that these were the 2 factors that add up to +21, and then I was able to build this. After that, I set them equal to 0, as you can see. I solved for them. The biggest thing that I got is that I was able to discover my complex zeros. Okay, moving on to this one. One of the biggest things you got to remember when you work with logs is that this division that you see here shows up as a minus right here. So that's the first thing I did. If you notice, everything stays the same. I just took them apart, wrote the same base. And then after that, each multiply you see here shows up as a plus. So multiply there, plus there. And then after that, the only other thing you got to remember is this. This 2 goes in the front. Every time you see a power, it went to the front. So after that, I was able to achieve my solution. Now, when you're compressing, you do everything backwards. You start with the powers. So the first thing I did is I took the 2 and I placed it back. That's why you see a 2 here. Take the 3, place it back. That's why you see a 3 here. After that, I started compressing. I made the add into a multiply. And then after that, I went ahead and made this division into my final solution you see here. Now this one's actually, I love the question 17. It was pretty simple to do. All you had to do is understand that then minus became a division, and then this became a solution. Oh, just realized something. Log of 2, pretty sure that this is factorable, and I think it is. I would, yeah, it's going to be -1 x minus 4. That factors, and this is x minus 1 squared. The reason why this is important is that this and one of those are going to cancel, so your actual solution simplified is going to be x minus 4 divided by x minus 1. Okay, good. Now, for solving these equations, one of the things you got to remember is what they call the log loop. And so when you want to solve a log like this, first thing I did is I took the add and I made it into a multiply. The reason I did that, it makes it, now when it's combined, I'm able to do the log loop. What the log loop is you move this, change its place. This 3 moves, changes place, and becomes the base. So if you could see, that becomes the base. After that, I was able to solve for it, made it into a quadratic, and I went ahead and solved that there was 2 solutions for this. Now with this one has a theory that, you see the 3's right here? It makes it that it guarantees me that this needs to equal this. Or in other terms, this equals this. And I went ahead and did a 2-step equation, or multi-step equation, and I was able to solve that this x was the solution. Now, anytime you want to verify if it's correct, you have the power to use your calculator to see if it's correct. Now, on this question over here, I went ahead and made that division. Afterwards, since I have the same base, anytime you have the same base, you're able to put them equal to each other like this. And what that gives you the power to do afterwards, I divided by 3 to both sides, became the solution of x minus 1. This one was just a log loop. So again, pause the video, write it down, but go ahead and make sure you understand it. Now, when you want to do a change of base formula in your calculator, it's very simple. All you got to do, though, is you got to do this. And then you get the solution. Okay, let's go to number theory, which is arithmetic sequences in a series. Now, with this one was very easy because they want you to write the first 5 terms. N equal the first 5. Here's the first 5. And then afterwards, here's your solution for your answers. And this one, you got to find patterns of rule. Now, the biggest thing you got to remember is this equation right here. A sub n is equal to a sub 1. And d is a constant difference. If you have a constant difference, this is arithmetic. And arithmetic happens when, I could guarantee your arithmetic sequence, when it's plus or minus. So one of the things we discovered with d is 6, and then 3 is a sub 1, and you substitute it in, you get the solution. With this one, I was able to be guaranteed a geometric with equations slightly different because of the multiply. If you have multiply or divide, a constant multiply or divide, you're going to use a geometric, which indicates you're going to use this equation. You're going to solve for r, which is a constant multiplication between the numbers, and then you're able to just input it into the equation. Now, when you do a summation expansion, this tells you where to start, tells you where to end, and it's telling you to add them all up. So one of the things that we did is that we started at 1, went to 2, and as you can see, I expanded it and then added them all up to get that solution. So when you see that, you got to be able to do that. Now, when you're talking about express the sum using this, one of the first things you got to do is look at the pattern. One of the things I was able to find is that you have n plus 1 and then 2n, describing the pattern. And it went up to 8. Just because if you put 8 in here, that's how you achieve the 9. So this was the way you got to do this. So you got to look at those and be able to discover them. Now, with the binomial expansion, one of the things you got to realize is you got this. One of the things I did is that you start at 5. So when you want to do an expansion of this, you start at 5, 0. Remember, this descends, this ascends. So descends, ascends. This one stays the same. This one ascends. This one goes up in value. So when we progress, I went to the 5th term. So when I wrote it all out, I got to this 5th term, and then I just solve for it. And then that's how I was able to achieve the solution for the fifth term. Now, when you do the binomial theorem, the biggest thing you got to do, and I'll scroll through all of this, is you got to be able to do this and choose R. Now, to do it in your calculator, all you do is hit the 8, and like you go to math. You see the PRB screen? Go there. And the important thing is you hit the end, choose R, which is option 3. After that, you hit 0, click enter, and it'll give you the solution. So you could do that for all of these. And you set it up just the way I did before. We're talking about ascend and descend. And then this became your solution. So let me go ahead and scroll through that slowly so you can be able to copy that. After it's pause it and copy this. Pause it and copy this. Again, try it again so you can make sure you understand it. With Pascal's Triangle is kind of easy to form. You start with 1 on either side, and then you keep on going. The biggest time saver you get with Pascal's Triangle, and you can see that adds up to that, that adds up to that, is that with Pascal's Triangle, you're given the power then to actually, all this, like this 1 is there, 6 is there, 15 is there, 20 is there, and then you do the same thing with the binomial expansion, but you save yourself the and choose R's as far as doing that. So go ahead and pause the video, copy all that down. Here, same thing for the geometric series, pause the video. What I love about this is it makes it very simple, because once you're told what the n is, you're able to fill that in directly too, and then get the solution. Now with this one right here, they want you to find the term, the 10th term. So just focus on this part of it right here. Oops. Let me do that. Let me go back. Nope. Here we go. Somehow I went a little too far. What I wanted to do is encompass just this portion of it. This is the equation, then after that you just apply it. So again, pause the video and write that down. And with this one, now this what's important, they want you to find the finite sum. When you have finite sum, you're guaranteed you're going to use that equation. So with the discovery of that equation and the values of finding a sub 1 and r, should kind of cover how to find, like one of the things I was able to discover that this one had an r value of 1/3. A1 is easy to find. It's always the first term on there. And then I was able just to input an equation. Here's my solution. Same thing goes with question 32. You do the same thing. Now, the only thing that's important about 32 is that this one's asking about infinite. So infinite, we got to go back to this theorem. If r is less than 1, then you're able to use this. And it was. R is less than 1. So then I was able to use it and find out the convergent series. That's another way to find out if the sum converges. You got to look at r. R is less than 1. I could use the equation. This one does not converge because if you notice the r is 3. Actually, should have been -3. So it does not converge. Okay, let's go over here. Now, when you want to convert with polar coordinates, one of the things you got to remember that was important is you plot it. Afterwards, you go ahead and use this equation. You have to find r because, see, the most important thing with polar describes everything in magnitude and direction. You know, like this. The unit circle was always described in theta. And one of the things that we did is that we went ahead, once you're able to find r, use this equation. You find theta using, this was y over x. So my y was -8 over 8, so which made the answer -1. And with that, I was able then to look at the unit circle and describe and find out that -1, in this case, was over here, which then became the angle. Oh, hold on a second. Let me grab my unit circle real quick so I can tell you the angle on this. All right, the angle was 3 pi over 4. So let's write that in. And then after that, this was my magnitude right here that I discovered using the equation. So my final polar coordinate is a squared root of 2, 3 pi over 4. Okay, now with polar, if you're ever given a polar coordinate asked to convert, it's very easy. It's just r is equal to cosine theta. And you're able to find the solutions for cosine theta and sine theta most of the time through the unit circle. So this you use the unit circle. Like, I could guarantee you that cosine -pi over 6, remember pi, now, remember, in the unit circle, negative goes this way. So -pi over 6 was the same value that way. So it was a value, it was actually that first value that was there. But one of the things I was able to discover that was important was this and this. And then after simplifying, get my solution. Okay, question 37, same thing. Now with 37 is a little odd though, just because when you did this one, so I think there was a typo in it, you got a decimal answer for your angle. So I actually put a decimal radians, which is not the right way. Now the other thing too is to remember is that if you move it the other direction, make a negative, you also have to move it by negative pi or 2 pi. There's different formulas for that, so you'll have the opportunity to use that. Now with this one, same thing. R, this is X, this is for Y. You just input the value R, that in there, what you see there, and then after you get that solution that you see down over here. Now with vectors, what's important with vectors is that you place out the vector, and what I did here is I distributed, and I got this 6i minus 9j. And same thing here, I distributed this, and I got this as a solution. So one of the things I was able to do afterwards, vector, the magnitude vector is here. Again, you can watch this, pause it, write everything down. First thing I had to do is I had to get this into a single vector. So after I got into a single vector, then I was able to use that here. Okay, again, this one I went ahead and used the vectors. I distributed first, and then I went ahead and added. And that became my solution. This one, again, got a single vector first. Here's my single vector. Then went ahead and applied my magnitude vector to get the solution here. Now the only thing I did over here is I simplified. So as you can see here, this is the simplified answer. Okay, great. Let's go ahead and move over here. Now with ellipses, they're very easy to do. We covered this just recently. So I'll kind of glance through this, but this is the solution. With this one too, go ahead and pause the video. Write all this down. This is a hyperbola. This is how I went ahead and discovered this parabola. Here with this one, I had to do some manipulation with this. This is a parabola. And I knew what the center was because it was set up in vertex form. But I also was able to change it up so you could see how I ended up getting the solution there. Now the law of sines, law of cosines. Okay, every angle, every triangle was set up like this. And depending on what you had, you either had to use the law of sines, law of cosines. Like in this case, one of the first things I did, what I was given, here's the work. Go ahead and copy this down. But I went ahead and discovered that I could use the law. I think I was given side, side, side. Side, side, side is law of cosines. Use the equation twice, and then I was able to discover the rest of the solutions. This one, once I wrote down the given information, was law of sines. Now remember, you just cross multiply and divide. Cross multiply and then divide by this answer there. So it's very simple to do these. I love them. Easy to do. I found A and then I did it again. Let's see. Cross multiply and then divided by this one. Here's the other one right here, number 49. Here's the law of cosines. As you can see, same thing. Here's the solutions. You go ahead and write them down. Pause the video, write them down. Here's the next one. Same thing. Pause the video and you can write them down. Use the law of sines on this one once I did the setup. And then pause the video and you can look, verify what I did. This one, go ahead and same thing. Pause the video and you can see what I did. This one I used the law of cosines. Once I did the setup of the triangle, I went ahead and used the law of cosines, and I was able to discover these as solutions. So again, pause the video and write this down. Now with these were application questions. Biggest thing you got to do is like this was my unknown. Everything else here was pretty much given except for one of the angles which you're able to solve for. With this one, the only thing you did not know, not given, is that that's a 45-degree angle if you cut it directly in the middle. And then you were given that one side is 90 because of the cube, and then one side was 129 with the picture mounts at. And then you use the law of cosines to go ahead and solve for the rest. With this one, you got to use a compass. But remember, anytime it talks about southeast, it's talking about directional point, or east, northeast. And these were the solutions, and this was the answer for this one. And then for the back, the vectors. Okay, what was important about the vectors, once you tried it, is you did the setup. So this was original setup, but then I knew I was given this angle. I was able to discover this other angle because that's a complementary angle to it. So I was able to solve for that, and then I just moved it. This vector, technically, I just moved it there, which is that vector there, the vector there, and then I was able to use the law of cosines to go ahead and solve for this. Same thing with this one. Now, except when it turned, this was 30. Since it turns this way, and this is a compass, basically. That means that this is 90, which guarantees me that this is actually 120 degrees. So that's how I was able to get this answer there. This one here is the last one for moving the boulder. Same thing, same concept. This got moved there. Found out what this angle was, because that was the angle that went there, to use it for the law of cosines to discover what the two magnitude forces were together. Now this one I think is the easiest one to do. What I find so simple about it is that I went ahead and lined them up, and you just add them all together. So that's your solution. That's your solution. Well, this becomes your solution right down here. But go ahead and try it on your own. So make sure you're able to do it. Okay, I hope this is helpful to y'all, and go look on the test.